we're going to do this problem together. This is the type 4. The reason this is a type 4 is because now we're not just adding or just multiplying, but you're going to be doing both in a problem. So we have to follow some order of operations here. And then we're going to look at standard F2, which once we talk through the front page of standard F2, the problems are very easy as long as you understand the pattern. So we work a lot with the pattern. All right. When you're multiplying, or let's say we had something that looked like this instead. Whoops. Okay, so same type of operations going on here. What would I have to do first? The multiplication or the addition? Multiplication, because please excuse my dear Aunt Sandy, which is what most of you learned. So you'd have to do the multiplication first and then add. The same order of operations would apply here. So even though we have an addition and a multiplication, we're going to have to multiply here first. Now, when you multiply that together, you have to look and see if you can factor anything. Can I factor any of these numerators or denominators? No. But I am going to keep the denominator separated. I'm not going to, because otherwise I'm going to have to do it again. Like, if we were to multiply this together by distributing the x through, when I get down here to add, I'm going to have to factor it again. So I'm just kind of saving myself a step here by keeping them separate. Still show the multiplication, so x times x minus 5. But on the top here, I'm going to go ahead and distribute. So 4x minus 8. Okay, and now that we're adding, what do I have to do with this denominator? To factor, and that is a difference of squares. So if I factor that, I'd get x plus 5 times x minus 5. Okay, so in my denominators, how many different pieces in my denominators do I have? Some people I see 2 fingers. I have 3. I have the x minus 5 factor. I have the x plus 5 factor. What's my third one? The random x there. Okay. So, in this first fraction, I'm going to need an x, right? And in the second fraction, I'm going to need an x plus 5. Okay. And then let's go ahead and simplify the numerators. So, I'm going to distribute this x through that expression on the top. So I get x squared plus 3x. And the bottom is just going to be those 3 factors put together. And then what do I have to do here in the second fraction? FOIL them. Good, because they are 2 binomials. So we can kind of do this and simplify at the same time. So 4x times x gives me 4x squared. My outer gives me 20x. My inner gives me what? Negative 8x, so 20x minus 8x gives me 12x. And the negative 8 times 5 gives me negative 40. Okay. Am I all set to add now? Yeah, because I have common denominators, so I'm good to go. So we're just going to add across the top. When you add across the top, you add like terms, so x squared plus 4x squared gives me 5x squared. Then I should have 15x minus 40. And can I leave it like that, or do I have to do anything else? Can I leave it like that or not? Yeah, I can leave it like that. Just box it and that's your answer. Okay. Alright, let's go ahead. You'll get more practice on that today in several different ways. Flip to standard F2. That problem we just did will be a good transition to this one. Alright. So there's this thing called the binomial theorem, and then there's a little pattern that we use called Pascal's triangle to expand expressions. For example, we have been very good so far I may be expanding something that looks like that. By expanding, I mean multiplying out. What does x plus 2 squared mean? X plus 2 times itself, right? So if we were to expand this, you'd have to do what with those? FOIL them, right? And you get x squared plus 4x plus 4. Okay, we've been doing that pretty much since the beginning of the year, or beginning of the semester. We're pretty used to that. What if I had something like this? What does that mean? 3 times. Now, could I still FOIL? Right, but we've done problems like this where we can only FOIL 2 of them together at once, so we'd FOIL those together, and then we'd have to take that and multiply it by x plus 3. So it's like a 2-step process. I'm not going to make you do it here. What about if I had something like that? What does that mean? X plus 4 times itself 8 times. So there'd be a bunch of FOILing, a bunch of multiplying. How long do you think it would take you to do that problem? Probably a long time, because that's a lot going on there. Not that you couldn't do it. It would just be a lot of steps and a lot of multiplying. And your equation would end up being long. Okay? So, we're not going to actually make you write that out. But that means multiplying by itself 8 times. So I'm going to have you repeat that little expression here. If we were to simplify something like that, x plus 4 to the 8th, we would have to multiply x plus 4 by itself 8 times. And we all understand that would take us a long time. It's doable, but it would still take us a long time. So, thankfully, there are 2 concepts. First one's called the binomial theorem. And then in kind of partnership with the binomial theorem, there's something called the Pascal's triangle. Pascal is a guy. Blaise Pascal was his name. He's the one who came up with this pattern that follows this expansion thing with the binomial theorem. So this type of problem becomes actually very simple with no work at all, because it follows the binomial theorem pattern. Notice with the binomial theorem, bi means what? 2. Nomial means numbers or terms in this case. So you can only do this with a binomial. So when you have a plus b, or 2 things added together, or even subtracted, it works that way too, raised to some kind of power on the outside. To expand that, we're going to have to write this a little weird. Let me see how they wrote it here. I'm going to simplify it how it's usually written. Okay, we'll do it this way. C in all these cases is going to represent a constant, so a number in front. So C times a to the n times b to the 0. I don't know what n is right now, but that would be what our first term would look like, whatever n is. So if n was 8, then it would be a to the 8th, b to the 0. What's anything to the 0 power? 1. So we really wouldn't even have a b term in the first one. Okay, then we're going to add another constant, and that would be my second term. Now, the actual way this plays out with an actual problem isn't going to look this complicated, but I'm trying to show you the pattern that occurs here. The next one would be C So you may see a pattern forming here with my exponents. This one, what happens to this one? So if this was, let's say, an 8, if n was an 8, then my first term would have a to the 8th, the second term would have a to the 7th, the third term would have a to the 6th, and then it would keep going down from there, right? What's happening to my second term? It's going up by 1. So you start at 0, and then you add 1, and then you add 1, So it's going to keep going. So the next term would be a b cubed. Next, and the term after that would be a b to the fourth. So your first term is going to be decreasing in exponents. Your second term is going to be increasing in exponents. And I'm going to put a little dot, dot, dot here, and then we're going to write the last term. It's going to be some c constant. We're eventually going to get to the point where whatever n is going to end up being 0. So if it is 8 terms later, you're going to have 8 of the 0, because it's going to decrease by 1 every time. And then what's going to be the exponent for the b in the last term? N. Good. Now, in the binomial theorem, the c's which my c represents the constant. So c comes from the appropriate row in the triangle. Okay, because these constants aren't just one number. They are going to be particular numbers, and it's all based on this pattern with Pascal's triangle. Okay, Pascal's triangle, I don't make you memorize it, you have to know the pattern of how it's set up. It starts with a 1 on the top. It is going to look like a triangle, but it's going to be a group of numbers that forms a triangle. The next row wait, you know what? That's a 2. Sorry. 1, 2, 1. Next row, I'm just going to double check. Oh. Nope. I was right the first time. Sorry. Erase or cross out. I messed up the first row. Alright. It was 1 and 1. The next row after that is 1, 2, 1. There we go. The next row after that is 1, 3, 3, 1. The next row after that is 1, 4, 6, 4, 1. Notice how the numbers are kind of like, they're not like right underneath of each other, they're kind of in between the numbers on the previous row. Next one's going to be 1, 5, 10, 10, 5, 1. Does anybody know here what this next number will be? Because this is following a pattern. 6. Good. 15, 20, 15, 6, 1. Good. Now, I could keep going, but we're going to stop there because this will get the point across for the pattern. Okay? The first row is considered row 0, so you might want to write that. We never use that row for anything. We also never use really row 1 for anything. Because when we're expanding, really the only expansion is going to be when you have a power of 2. So this is row 2, and then it goes on from there. If you notice, you have 1, 1, 1, and then to get the 2, it's like you added the 2 numbers above it to get this number. So 1 plus 2 gives me that 3. 2 plus 1 gives me that 3. 1 plus 3 gives me that 4. 3 plus 3 gives me that 6. 3 plus 1 gives me that 4. And then that follows the same pattern over and over again. So on your own, I want you to try to do the 7th row. So basically, to get the number underneath, you're adding the 2 numbers above to get that new number. Is that what you got for the 7th row?
Yes.
Good. Okay, so that pattern is going to keep happening over and over and over again. So if we needed row 8, we would be able to get to to row 8. I'm not going to give you probably something at row 8. Usually you're going to have to expand something that's like to the cube or to the fourth or to the fifth. Those are the most common ones. But we use these constants. Okay? So go ahead and flip. And we're going to do 4 examples together. We'll start with an easy-ish one. X plus 5 to the 4th. Okay? So this gives you what row to look for your constant. So we're going to look at row 4, which is this one right here. These become my constants. Whoops, not that you can see that, sorry. These become my constants. So when I set up the expansion, I usually start by listing out my constants. So 1, 4, 6, 4, 1, right? These are, so when I expand this, I'm going to have 1, 2, 3, 4, 5 terms listed. This is my A. This is my B. So in the pattern, my A starts at, well, our N here is 4. So your first term is going to start with the exponent of 4 and go down for each term. Your second value, which in this case is 5, is going to start at 0, so it's not going to be included in the first term, and then increase an exponent past that. Okay, so this x is what I usually deal with next. So we do x to the 4th, then the next term would have x to the what? 3rd. And then we have x to the 2nd, x to the 1st, and x to the 0. Now I'm going to write x to the 0 there just because. And then I deal with the second term. So this one's going to start at what exponent? 0, and then increase from there. So we have 5 to the 0, 5 to the 1st, 5, what? To the 2nd power, 5 to the 3rd power, 5 to the 4th. Now, you're adding between all of these terms. But those are my 4 terms. And what do you think the next step is past that? Once you set up the pattern, then probably simplify, because we've got some numbers that we can simplify. So this first term, 5 to the 0, anything to the 0 power is 1. So really I just have x to the 4th, right? What's my number in the second term? I have 4, and then I have 5 to the 1st. Everything there is being multiplied, so do you think it's fine if we multiply the 4 and the 5 together to get one number?
They're not like terms.
Well, they don't have to be like terms. In this case, they're all being multiplied. So if you have 4 and 5, you can combine those to give me 20. Because all of that is being multiplied. So if you can multiply numbers together, do it. And then what are the 2 numbers that I'm multiplying in the second term? 25 and 6. So that's going to be a pretty big number. What is it? 25 and 6.
Oh.
Because we have that. 150. Good. 150x squared. And then this next term, I have 4 times 5 cubed. 5 cubed is 125. So 125 times 4 gives me 500. 500. Yep. So do you think it's pretty common that my numbers get big in these? Yeah, it can be. And then the last one, I have x to the 0, which is just 1, and then 5 to the 4th. 120, it'd be 125 times 125 times 125 times 1. Alright, what am I saying?
Whoa.
5 times 5 times 5 times 5.
So it'd be 125 times 5.
And that's what you said. Yeah. I'm losing it. So 125 times 5 is 625. I don't know what I was saying. Okay. And then that would be the simplified version. I will want to see that your pattern is all written out like this before you simplify. Just so if there's a number that's off, I kind of see where you went awry. Okay. Let's do another one. I'll keep this one a little shorter. Alright, so the 3 tells me what row to look at for my constants. Row 3. So, we start with the constants. So I'm going to use those 4 numbers, 1, 3, 3, 1. So I space them out, 1, 3, 3, 1. And then I go to my first term here. And then that's going to decrease an exponent, but what's the first exponent that I start with? 3, and then it goes down from there. Now you have to be careful when you already have an exponent on the term. That's being raised to the 3rd power. It's whatever the first term is being raised to the 3rd power. So that's raised to the 3rd. And the next one would be to the 2nd. Then the 3rd one would be to the 1st. And then the last one to the 0. And then your second term in your binomial is going to increase an exponent, but it always starts at the exponent of 0. Okay. And then we simplify. Now this is using some properties of exponents. When you have a power and a power, like we do here in the first term, what do you do with the exponents? Or multiply. Because x squared cubed means x squared times x squared times x squared, right? So if I have x squared, and x squared, how many x's do I have? I have 6. 2, 2, and 2. So you would multiply those together. So my first term would be x to the 6th. My next term would be 3x to the 4th y plus 3x squared y squared. And then what's my last term? 1 It'd just be y cubed, right? Because anything to the 0 power is just 1. And then you'll be done. Okay, we're going to do one more together, and I'm going to have you do one on your own and see how close you get here. Let's go with 3x squared plus y cubed, and we're going to do that to the 4th. Okay, so you look at row 4 to get your constants that you're going to start with. So 1, 4, 6, 4, 1. And sometimes students like to put the addition signs right in front right away, so they remember that it's all being added together. So your first term is added by your second term, so forth and so on. Then we start with my first one here, and that's going to have to be raised to the 4th. My first term. And then cubed in my second term. Just write the same thing, basically, just decreasing exponents along the way. And then your second term, your binomial will increase in exponents. So, looks like a lot going on, but just deal with one term at a time and simplify within that one term. Now you have to be careful here. With this first term that's raised to the 4th, the x squared is being raised to the 4th, but also what's being raised to the 4th? The 3. So what is 3 to the 4th?
4, which is 81.
Which is 81. Good. So you have 81. And then what's my x exponent? Careful. should be 8. When you have power and power, you end up multiplying them together. So we have x to the 8th, y, oh, just kidding, no y, because it's raised to 0 power. So we just have 81x to the 8th. The second term, let's do the power first. So 3 cubed is 27, but then I have to multiply that 27 by what? By the 4. What is 27 times 4? What? 108. And then we have x to the 6th, y cubed. Next term, 3 squared is 9. 9 times 6 is 54. What's the exponent on my x? 4. And then what's the exponent on my y? 6. Okay, moving right along. What's the constant in my term, or my next term? The number in front. 4 times what, though? 3, right? Because I have 3 to the first, so it'll be 3 times 4 gives me 12. And then x squared, because 2 times 1 is just 2. And then y to the 9th, good. And then the constant in my last term is just y to the 12th, yeah. My constant would just be 1, because this ends up being 1. So yeah, you just get y to the 12th. Okay. Think you're ready to try one on your own for example 4? Can you at least try one on your own? Okay, let's go with x plus y squared to the 5th. I'm not going to do anything to the second, people. You know how to FOIL. I gotta have you know the pattern. Okay, so I'll give you a new row, but I didn't really give you any crazy constants there. So try it on your own first, and then maybe check with somebody around you. But obviously we'll go through it together. if you want to check your work, that's what you should have. Any part of that people got hung up on, or what do you think is the most confusing thing, or thing you have to really think about? I heard somebody say exponents over here. Do you guys get the pattern, and maybe it's just the exponents that are making some of it a little difficult? No feedback? Well, we'll see how you guys do. If you would please get with Polynomial Partners today. You'll need paper if you want clipboards underneath there. There's 10 problems around the room. Practice this, but also adding, subtracting fractions, and multiplying. Dividing fractions. So this is like around the world problem and answer thing. So you can start at any paper and work your way around.